Alrighty, welcome back. This one's a weird looking proof and it's pretty long, so let's go ahead and take a look at it together. Write a two-column proof for the following given that M is parallel to N and the measure angle 6 is 60 degrees. Prove that the measure angle 3 is equal to 120. Okay, so let's go ahead and take a look at the given. Okay, so M is parallel to N. So this line, parallel to each other. So I'm going to go ahead and draw my arrows to show that they are parallel. And the measure angle 6 is 60 degrees. Wonderful. Just by looking at the proof here, that's 120 degrees, right? The measure angle 3 is 120 degrees. 60 plus 120. That looks like that's going to equal, if I add these two angles together, that's going to be 180 degrees. So let's go ahead and take a look at that measure angle 6 again. So it's here at 60, right? And my goal here is to prove that measure angle 3 is 120, right? And I notice, this if I look at this 3 and 7, they're pretty much on the same side, right? So if I can, this whole thing is 180 degrees, and I know that angle 6 and angle 7, for sure, that's going to be congruent. Angle 6 and angle 7 are congruent by the vertical angles theorem, right? So measure angle 7 is equal to 60 degrees. So this is 60, 120, same side. These angles have to be, angle 3 and angle 7 has to be supplementary by same side interior angles. They have to be. They have to be. So could that be my game plan here? Let's go ahead and try and test all that out. So again, given M is parallel to N and measure angle 6 is 60, so M is parallel to N and the measure angle 6 is equal to 60 degrees, and that has to be my given right there. And I see that angle 6 and angle 7, that's congruent. We've already talked about that. That's because vertical angles has to be vertical angles. Okay? Now converting, since this is in the language of geometry, and this is now in the language of algebra, that's just me converting the languages, so that's definition of congruence. Okay? And then what else do we notice? Well, we notice that angle 3, because now I went from 6 to 7, right? So angle 3 and angle 7, they are on the same side of the transversal. So that means that I just write angle 3 and angle 7 are supplementary. Sup for short. And now I'm converting this language, angle 3 and angle 7 are supplementary, to algebraic form, and that's just the definition of supplementary angles. Okay? I mean, you can refer back to your pink sheet here. So we know that the measure angle 6 is 60 degrees, right? So if the measure angle 6 is 60 degrees, then that means that the measure angle 7 is also 60 degrees. And that's just me, measure angle 3 plus measure angle 7, that becomes 60 degrees here. That's just me replacing, right? So that's substitution. Then, to solve for the measure angle 3, right? 180 minus 60, that's 60 degrees. So that's the subtraction property of equality right there, okay? So that was pretty much my game plan for that. Let's take a look at number 17. Write a two-column proof for the following, given that angle 1 is congruent. Sorry, there should be a space right there. Angle 1 is congruent to angle 2. Prove that M is parallel to N. Angle 1 is congruent to angle 2. So remember, this stuff is given, right? That's what you can assume. That's what you can use. So mark. Angle 1 is congruent to angle 2. Okay? And my goal here is to prove that M is parallel to N. I cannot assume that M is parallel to N because that's my job. I'm trying to go from one step to another step to another step to m is parallel to n, if that makes sense. So because I'm proving that m is parallel to n, I have to use a converse theorem. I need to use one of the converse theorems. Okay, I got to use one of the converse theorems. So, y'all, let's take a look. So angle 1 is congruent to angle 2. I'm not looking at this. Don't look at this. Angle 1 is congruent to angle 2, but notice that angle 2 is congruent to angle 3. Why? Because, of course, vertical angles, right? So we know that angle 1 is congruent to angle 2 by given, because that's what we can assume, and angle 2 is congruent to angle 3 by the vertical angles theorem, which we also can use because it's a proven theorem. And anything that's proven, we can use for our proofs unless stated otherwise. Okay, so vertical angles can be used in this case. And then, okay, well, angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Y'all, that looks like this is a transitive property sort of thing. So that's transitive property right there. Trans are short. So then, angle 1 and angle 3, just by looking at it, angle 1 and angle 3, they are corresponding. Again, these lines cut by a transversal. If you're standing at 1, you're basically standing at 3, right? You're comparing one region to another, angle 1 and angle 3. So we can say that since 1 is associated to m and 3 is associated to the line n over here, we can say that m is parallel to n. And based on the positioning right here, these are corresponding angles. But really, in particular, the reason is they are parallel because of the corresponding angles postulate. Okay, so let's go ahead and plug everything in. Angle 1 is congruent to angle 2. That's a given. And then we can see that angle 2 and angle 3 are congruent. That's because of the vertical angles theorem. Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. That means that angle 1 has to be congruent to the angle 3. Transitive property. So therefore, whatever you have, whatever you're trying to prove, you put it in this little box right there. So m is parallel to n because of the corresponding angles postulate converse.